To begin, at the beginning. No space, no time. Everything in the known universe compressed into a dot smaller than an atom. Suddenly, out of this, the universe expands. Stars and galaxies form, creating the cosmos we see today. The story of our universe starts with a Big Bang, or does it?
So the Big Bang is the observed truth, but there are details that haven't been quite worked out.
There are a lot of things that may have happened. It's just one explanation.
Science isn't about being right all the time. It's about being wrong. And we could absolutely be wrong about a major component in our understanding of the universe.
We're putting one of science's greatest stories to the test. The Big Bang sure sounds like an explosion. But was it? An explosion is a sudden release of energy from one point, usually generating light, heat, pressure, and a bang. But did the Big Bang even explode?
When you hear the term bang, you think of a noise, but you have to realize that it's sound waves propagating through air. So after the Big Bang, there's no air. There was no air, there's no way to hear anything. So in that sense, it was silent.
So the Big Bang didn't bang. But to make the universe, it must have pushed out stuff. Lots of stuff. Every explosion has an ignition point. What about the Big Bang?
So if you were to only think of the Big Bang as an explosion, you would very rightly ask, well, where's the center of that explosion? Where is the center of the universe?
There was no central point. There's nowhere in the sky you can point and say that's where the Big Bang was.
The Big Bang is everything. The Big Bang happened here, where I'm sitting. The Big Bang happened on the other side of the planet. The Big Bang happened in the Andromeda Galaxy. The Big Bang occurred throughout the universe simultaneously.
During an explosion, debris fires out from the center. This debris spreads out unevenly, with different-sized pieces landing at different distances from the blast center. But did the Big Bang shoot material out in this explosive manner? For clues, we need to search the night sky.
One of the things that's really very striking about the universe when you simply take a telescope and start looking in different directions is that it, roughly speaking, looks the same in all directions.
Although the universe is peppered with individual galaxies and galaxy clusters, the big picture is what astronomers call homogeneous.
When we say the universe is homogeneous, it means it's almost exactly the same on very large scales with very, very little differences. It's perfectly smooth.
If we believe the classic Big Bang story, the same amount of material was shot out over the same distance in all directions. Our smooth, homogeneous universe doesn't appear to be the result of what we know as an explosion.
It wasn't big, and it wasn't a bang.
The Big Bang was not an explosion like a grenade or a bomb or dynamite, where there is material rushing out from a common center.
It's not like there's a ring of galaxies that came out from some explosion.
A firecracker explosion is triggered by a fuse. So, what set off the Big Bang?
What I would say is there's no such thing as what triggered the Big Bang. You know, we tend to think when something happens, when there's an effect, there was a cause, right? There was something that made it happen. But here we're talking about the whole universe. There's nothing outside the universe to bring it into existence.
The science is clear. The universe did not start with an explosion. But if there was no bang, then how did everything start so small and get so big?
The young universe, we do understand. In the old contemporary universe, we also understand. We've stitched together this story where we don't fully understand the first few paragraphs of the story, but we know the rest of the book.
How can we get to the bottom of the Big Bang story when we can't even read the first page of the book? The only hope we have is to search back in time, line by line.
One of the amazing things about being a cosmologist is that telescopes are time machines. It takes a while for light to get here, so if we look farther out into space, we're really looking back into the history of the universe, and that's amazing.
The first clues to unraveling the Big Bang mystery came with the introduction of advanced telescopes in the 1920s.
Edwin Hubble was studying the light coming from distant galaxies. And what he realized was the more distant a galaxy was, the more reddened the light was. Why should that be? Well, it turns out that light reddens if a galaxy is moving away from us. It's called the redshift. So what he discovered was pretty much every galaxy in the sky was moving directly away from the Milky Way.
This was truly one of science's landmark moments. Hubble had proved one of the basic principles of the Big Bang story. Our universe is continuously expanding. There was only one conclusion to draw.
If you extrapolate that back in time, it looks like everything was coming from one point at one time. That's the Big Bang.
Hubble's discovery grabbed the headlines, but the idea of an expanding universe had been proposed 2 years earlier by a Belgian priest and physicist.
The real idea of the Big Bang comes from Georges Lemaitre. He realized that if you ran time backwards, back to the beginning of time, maybe everything coalesced into a single atom, the primeval atom.
Lemaitre believed the infant universe was extremely small and dense, squeezed into a single point. The primeval atom. Later, scientists would define this point as an infinite entity called a singularity. But there's a problem. The singularity and the laws of physics don't mix. It may be one infinitely small point, but it causes some impossibly big problems.